Hey guys, Mr. Bowman here. Today's learning objective is in yellow and we are learning to describe the key features and assumptions of a binomial distribution. Our starting point is kind of how to describe a binomial distribution, and for me, I describe it as the distribution of success or failure. And I'll run through a couple examples of what I mean by that. And the obvious one is I've got 2 coins in my pocket. What is the probability of me getting a heads? So by saying what is the probability of getting heads, I've defined heads as a success and tails as a failure. And that's because I'm looking for a heads and looking for a tails and not looking for a tails. And the same again, so heads, that would be a success. Tails, that would be a failure. Heads would be a success and tails would be a failure. And we all know the probability of all of these is 1/2. So while I'm finishing writing those up, I was interested in, well, what's the probability of getting exactly one head? So we need to run through our combinations, and I'll explain how this links to distributions quite well. So that would be a tick there. Tails, heads, well, that would be a tick because there's both one head there. There's 2 heads up there, so that's across, and tails, that's across as well. Well, that would be 1/2 times 1/2 equals 1/4. 1/2 times 1/2, and that equals 1/4 as well. And those combined, 2/4 or 1/2. So in our case, the probability of getting 2 heads, one head, would be 1/2. Well, what if I asked you, instead of having 2 coins, what if I had 3 coins? What would the probability of getting 1 head be then? While we could calculate that, so we can just extend our probability tree, it does just get a bit messy, and calculating all that just becomes more and more complex. What if again I asked the same question, but I had a 4th coin? So we can see how messy this gets. And then again, maybe I asked you that with a 5th coin. So while the maths we can do with a probability tree, it just becomes messy and unwieldy for this type of thing here. So what we do instead of that is we will be using the binomial distribution to figure out the probability of success or failure in a given context. So I'm just going to remove our probability tree just to explain what that means. So we just figured out the probability of getting 1 head with 2 coins was 1/4. So let's just write that down so we can refer back to that later. So 1 head from 2 coins, we said that had a 1 in 2 chance of happening. So what I'm going to do is I'm going to write down the formula for percent distribution, which we'll explain in more detail. So the probability of getting x is equal to NCX times the probability times 1 minus the probability to the power of n minus x. So it looks like a messy formula, but there are only 2 things we need to know in this area. We need to know what n is, and we need to know what x is. N relates to the number of trials, and in our case, that's the number of coins that we're throwing, so that would be 2. And x relates to the number of successes that we're looking for. And success can be anything that you define as success, and in our case, that's 1. So if we put that into our formula, so what's the probability of x being equal to 1? That would be 2c1 times p. Well, the probability of a head was 0.5 to the power of 1 times 1 minus 1/2 to the power of 2 minus 1. So if we have a think about what this formula is doing, this is asking you, if you had 2 coins, how many different combinations can you get? And that actually comes out to 2. We're going to times that by this. So this is the probability of success. So we're looking for 1 hit, and the probability of that 1 hit is 0.5. So that would become 1. And this part here, this is the probability of failure. So we're looking for 1 minus the probability of success. That comes to 0.5. And 2 minus 1, it's the leftover trials, or the trials that were failed as well. And that also comes to 1/2. And then when we do that, so that's 2 times 1, which is 2, divided by 4, which comes to 1/2. So you can see how we've got to that formula. And key thing to note, I did forget it at the top, but the probability, or P in that formula, that's the probability of individual success. And that's the third thing that we need to know how to calculate. So big nasty formula. Hopefully that made sense. What we're going to do is I'm going to clear the screen. If you haven't written notes down about the formula and how I describe a binomial distribution, please do. I'm going to pause the video. We're going to go into the assumptions, and then we're going to stop and hopefully get into some questions. So like all the other models, the assumptions, they basically describe what the model is doing. So the first assumption is, well, we're dealing with the number of heads that came up. The number of heads is a discrete data because you can't have part of a head. You either get it or you don't. So our first assumption is we must be using a discrete variable. Number 2, there must be 2 outcomes. And this is where I mentioned the success or failure. And that is what we define as a success or a failure. If you think of a dice, a success could be the probability of getting a 5, or a failure could be not getting a 5. So you can define it really widely as well. Number 3, there must be a fixed probability of success. And what that means is the probability of success shouldn't change for future trials. So for example, when we're flicking that coin, the first coin, the probability of success was 1/2. That didn't change the probability of the second coin, which was also a probability of 1/2. Then number 4, they must be independent, and that does relate, 3 and 4 do relate to each other. So the first outcome must not affect future outcomes. And the last one is there has to be a fixed number of trials. So we can't just say what's the probability of flicking a coin until I get a heads. That doesn't really work. There has to be a very limited number of trials. In our case, it was 2. If we used 3 coins, it would have been 3. If we had 100 coins, our number of trials would have been 100. So those are all really important. So hopefully you found the video introducing binomial distribution useful. Just to recap, binomial distribution is the distribution of success and failure. The formula was up top. It does look very complicated, but it relies on 3 things, and our graphics calculator will support us with our answers. So we do need to know n, the number of trials. We do need to know x, that relates to the success we're looking for, how many heads. And we do need to know the p, or the probability of an individual success. And after that, we described the features of this model, and we created some assumptions, 5 assumptions, that need to be present for a binomial distribution to be appropriate. Hopefully you found this video useful. Make sure you've paused and got down the appropriate notes. Let's get into some questions.